So I will walk you through one more user case, which is ESP frequency monitoring dashboard, which was implemented recently for Mittelplatte team. And the main idea of this dashboard is to simplify the daily well and reservoir monitoring for Mittelplatte team. So as a background, all the wells which we have on Mittelplatte, they operated, they're equipped with ESP, electrical submersible pump. It's the main artificial lift method here on Mittelplatte. And we have around 25 production wells, which are active at the moment. So the main task for reservoir and production engineers to monitor all these 20-25 wells on daily basis and to monitor the main ESP parameters like pressures, temperatures, power consumption. And one of the most important parameters is ESP frequency change. And on daily basis, usually we check the changes in all these parameters in order to monitor the well behavior. And usually we check it in our real-time platform, which is called Tabis, with real-time data. And you can see the screenshot from our system here on the slide. So we go well by well and check the different changes and adjustments on the wells on daily basis and on well basis. And as I mentioned, ESP frequency, it's one of the main parameters which we monitor as well. And it doesn't change on daily basis usually, but when it gets changed, it's very important to capture this change. And also we try to track and store the list of changes of ESP frequency changes historically for each well. And the analysis which is done, which has been done before this dashboard is quite time consuming, and it takes time to check well by well and to find this ESP frequency changes and not to miss them in order to be on the same page. And now we can go to the next slide, please. So what was actually done, this dashboard, you can see a screenshot here. And the main idea is that ESP frequency changes are tracked and recognized automatically by a script which is running at the back end. And then all users they are notified about this change with a mail, which allows us to be informed about the ESP changes simultaneously at the same time. And also this is a dashboard, so it helps us to access historical data. So we can see the list of all ESP frequency changes in the last month or any other time period. And it's very easy accessible, and it's very fast to track these changes. And now I think I can show a small demo. Yeah, so in one of the dashboards here, we have this ESP frequency change dashboard. So it looks like a list of different events. And here we have all the wells where these changes happened. And then we have initial frequency and final frequency. So the difference which change happened and for how many hertz it was changed. Also, we have date and time of the change. And then if you want to see a chart with frequency change and to track the time, to see it in more details, then we just go on overview, click on the well, and here we can see more precise information about the change. Yeah, time, how it happened, with how many stages, and so basically main parameters, time frame, and the gradient. That's what we actually need for this case. And important is that here we can track all the events all the changes in the last time. And when we need this historical information, we can easily access it and find it here. So that's from my side.
That's great. Thanks, Ksenia. So what we thought would be interesting as well is if now Andrew Orvis is able to share from our side what that was like to build and show you a little bit about what is in the back end. So Andrew, would you like to take over?
Yep. So we'll jump to the next slide. So this will basically take us through, briefly take you through the pipeline of how this whole system works. So it will start with the event detection system built into Ingenuity, otherwise known as user limits. These are configured by any user based on tags. So as they go through, they'll trigger at a frequency change of 0.5 hertz. This will then get read into the Elastic database, which the node RED will be scanning through every 50 minutes, and will find all the events of that time. It will then create an event based off this back into the Elastic with more information like the initial frequency and the frequency after, so the change amounts and all that. This will then be read back into Node-RED by a dynamic dashboard API, which will use this data, parameterize it into an API response, which will be fed into the front-end Ingenuity. I'll just quickly show you here. So as was demonstrated, we had the two tables. This was the first one on the first page. Oh, actually, sorry. Before that, getting ahead of myself. We have the event generation. So these are all the nodes we use to create functions. So the first one's a simple inject node, which is running every 15 minutes. And that, as I said, was scanning the user limit Elastic and finding every event that's happened in those 15 minutes. This will then move into a function node, which are these orange ones, which are kind of like our bread and butter. These all have JavaScript code in them and allow us to execute custom lines of code. So like in this one, we're building out a query for the Elastic for the start and end times of that 15 minutes with some overlap into a get node. So it will go into the Elastic and it will get that query, which will deliver us that information. We'll have another script node, which will basically process that response back from the Elastic and organize the events it's found nicely into a second function node, which will process them and design and put them into this, which is an event nicely organized with all its information. You can see it's got its tag, its corresponding well, start time, end time, and frequencies. So this will then be posted back into the Elastic as the ESP frequency change event. So to rephrase that, we've basically taken this change that it's found, which isn't necessarily frequency change. We'll then process it in the script to make sure it is a change, bringing in all its variables from the time it happened. If it is one, it will then process it into an event and put it back into Elastic. These events will then be read into the API. So whenever you've loaded the page, it will trigger this GET request, which will start this whole system here, which I'll show you an overview. It's quite long. So these first parts are just for basically setting up the page and its filters and getting things ready for the tables. So once it's in, it will move itself to this switch node here, which will either go to this page or this page, as you can see from the lines. As it starts, it'll go into its overview, which is the one I showed you with the table of wells and the latest change. So how these APIs are basically built, it's quite straightforward. We'll query the data that I just mentioned, the ESP frequency change event data will get queried. from that script and this get request node. And then quite simply, we will build out API responses using our widgets. So this will be the layout or the skeleton of a chart widget, or sorry, table widget. And interestingly, as you can see here, we are parameterizing our headers and rows. So basically, we're making them dynamic. So it will take in the values that we're calculating from this response and build the response off that. This will then be passed into a master response. So basically the whole page, and it will have all its widgets. So basically to summarize or refresh, what that's doing is we're breaking up the API response into different nodes, and we're parameterizing the responses of themselves. So we're passing in our own values, putting it into sections of an API, and at the very end, we're taking the whole thing, putting it together, and then sending it to the front end in this way. It's more obvious to see, I guess, with the second page, which has a table on top, a button, a chart, and a second table. So here we can see those, as in we'll have this table. This is actually the table at the bottom. So we've queried in all the historic well events for that one well with these two nodes. Again, a script node and a get node. We're generating another segment of an API response here dynamically. And then we're also querying a specific event, which is the one used for the top table and the chart. And you can see we're generating more nodes with a chart node, which will be another segment, very parameterized. We're even parameterizing the colors in this one. And we'll have that table. And then we'll have the button API. And then all these segments get passed into our master response. So this will actually be really long, but we like to break it up like this just to make it more easy to use, easy to work with. And then it'll be passed into the front end through this response system, allowing us to parameterize and change this. So as you click on things, it will change and dynamically form itself to the way we filter it. And yeah, that's basically it. Yeah, Merritt.
Thanks, Andrew. So I guess two questions. One is probably to mention that this is a dynamic dashboard, and in Ingenuity 7, you won't actually need to do any of that chart formatting now, because all you need is the data set, and all that formatting can be done in the front end. So it will simplify this even more. So the other question would be, how long did this take to make?
Well, this was one of our earlier ones, so this would have taken a bit longer than usual, but nowadays we've kind of refined our work pipeline with these. And like for these nodes, for example, like the chart node, we've really functionalized it, and we're basically trying to keep it consistent between all our dashboards. So we could get one of these out in a matter of hours, if even.
What, the whole flow?
Yeah. I said, because we parameterize these nodes, it will basically be like copy and pasting chart generations and such into let me rephrase that, sorry. We'll basically be copying out these charts and tables and buttons and then just pasting them into a new one and then swapping around stuff.
Okay, but I guess the business logic will take some time.
Yeah.
Up front. So there'll be some, I suppose the point I was looking at is that it might take maybe a week to turn this around from scratch.
Yeah, I mean,
Maybe 2
obviously
weeks.
they're all tailor-made and custom, so there'll always be that one or two things that come up that will, change things and extend
Yeah,
the pipeline.
that's right. But we don't have to then deploy code. This is all just done on the system as it is in that environment, easy
Yep.
to change.